Whilst many business eyes are focused on generative AI, quantum computing is quietly emerging as the next disruptive force, one that could supercharge AI and unlock solutions to problems that were once unsolvable. Quantum computing and AI are coming together to solve problems, not just today's, but technology problems that should be solved by tomorrow. For business leaders, this means faster insights, smarter decisions, and real competitive edge. Welcome, my name is Kieran and I'm a globally recognized authority in AI, automation and digital transformation. My extensive corporate background and deep practitioner insights offer the business world's a trusted advisor for today's uncertain companies. Today's guest is a US Navy veteran and seasoned transformation leader with deep expertise in AI-driven operational strategy. With a background at Gartner and PwC, an MBA in strategy and a track record of delivering measurable ROI, for private equity firms, he helps businesses cut through complexity, reduce tech sprawl, and unlock real value through intelligent automation. Welcome, Justin.
Yes, thank you so much, Kieran. Yeah, really excited to be on today.
Yeah, it'll be a lot of fun, So here, jump in. Let's give this audience what they want. What is quantum computing and how is it different from the computers we use every day?
Yes, I feel like there has been a microscopic lens into quantum computing as of late. Of course, the emergence of AI and now the emergence of quantum, one can start to wonder what exactly it is. So let's give some clarification to that. It's something that fundamentally redefines computational limits. So you can think about this technology. It's something that can supercharge AI by unlocking solutions to solve very, very complex business problems. It operates on the principles of quantum mechanics. So you can think about this as transforming how we process information at the levels down to neutrons, photons, electrons. The difference now, right? You can think about the difference when it comes to classical computers because they utilize bits of information represented by ones and zeros, on and off, if you will. Quantum computers, however, they leverage qubits. So these are things that operate in ones and zeros, but they can operate and exhibit superposition by representing one and zero at the same time. So, so I just said superposition. So let's go ahead and clarify and define that as well. So we'll dive into superposition, which is a phenomena of quantum mechanics, and then we'll also dive into entanglement briefly, which is also another phenomena. So superposition, it allows for qubits to embody multiple states simultaneously, right? So, the capacity of them being able to do that, it expands the information density or the ability to store massive amounts of information and ultimately process that information, right? So, when you think about a processor in this way, it can concurrently explore all the possible solutions to solve a problem, much like if you were in a maze. You're at the starting point, and every time you run into a roadblock, you have to go over again. That's the way that classical computers solve it. But let's just say there were 1,000 of you or 10,000 of you. You could explore all aspects of that maze simultaneously, and the one that reaches the end, maybe it takes, of course, you individually 5 minutes to explore a wrong answer or wrong pathway. Through through superposition, you can find the answer, let's just say in the span of 3 seconds, right? Comparatively. So that next concept is entanglement. So it links qubits. So once qubits are interacting with one another, they become correlated. So regardless of their physical separation, if they're separated by a nanometer or literally a meter, they can be represented in the same state, either that one or that zero. So these types of entanglements or intertwined calculations, it allows for computational advantage over classical machines. So it's something that business leaders can embrace, especially right now, because it's a fundamental shift and it offers the ability to solve extremely difficult problems to orders of magnitude faster. Just like I said, that maze example, 5 minutes versus 3 seconds, same thing. If you're a business leader that is going through logistics changes or transformation or workforce scheduling for 300,000 employees, or optimal pathway for advancement from a human capital and professional development standpoint, these are problems that you can solve almost instantaneously with these types of computers. So that's a little bit of in terms of the differences, but as I think about this going forward, rolling this out, the governance has to be robust, the cybersecurity aspects have to be robust. And then when you think about your current investments or investments going forward, it's something that you have to put a keen set of eyes on just so that you're executing is in the right way.
So if we do invest in that, then because it sounds exciting, and if it can solve really complex problems really quickly to get us to great answers, then which are the businesses that are going to benefit first from this combination of quantum computing and AI?
Yeah, absolutely. It's breakthrough technology. So, when you think about the difficult problems that typical companies have to solve, you can think about supply chain issues or financial services, or even, of course, in medicine and healthcare and drug development. So, in some of those examples, for example, portfolio optimization. So, which stock is going to perform much better given a set of criteria, or internal versus external factors, or other market players in the industry investing heavily in that same asset or potentially shorting that same asset. You can run a lot of those scenarios and then project and see what your potential outcomes are for that portfolio. Same thing for supply chain. Of course, there's been a wave of disruption in the last few years when it comes to supply chain. Um, Even in current present day, tariffs, of course, big shipping containers being stuck in canals and passageways. So it caused a wave of disruption. So you can factor all of those scenarios in through a quantum computer and then have it execute on the most optimal way to go about executing your operations going forward. And same thing when it comes to drug discovery, because computing is based on quantum mechanics operating at the electron, neutron, atom level. You can obviously think about materials engineering and then also drug development, even down to the different ways that humans are composed or have predisposition to healthcare issues, right? So you can run those scenarios and then get to, I would imagine the future state of this, having drugs that are extremely personalized to the unique makeup of a particular person. Great advantages. So those are some of the industries that can benefit immediately from this type of technology.
So you've got me excited then. So what are the biggest obstacles stopping quantum computing from being more widely adopted right now?
Yeah, there's a lot of limitations. At the base level, this technology, it operates with qubits. Qubits are in their natural state, if you will. They have to be extremely cold, right? So I forget exactly the degree, but the degree that you have to hold in terms of their temperature, it has to be at either 0 Kelvin or sub-zero Kelvin, right? Extremely cold temperatures, much colder than space itself, right? So
Mhm.
that's something that requires, of course, a lot of energy. And in order for them to operate optimally, they have to maintain that temperature, right? So they can become extremely unstable when they're exposed to external energies interacting with it. So any aspect of heat or movement or waves, radio waves or electronic waves, it might cause disruption in how they operate. And then, of course, if they're operating um, with your computations or your problems that you're allowing to try and solve, the outcomes or outputs may cause errors as well. So that's one thing, the qubit fragility aspect, but then the scalability aspect of this too. So as of right now, there are major entities out there like IBM and D-Wave and Rigetti major players in the quantum space, and they are operating with 5, 10, 100, potentially around 150 qubits as of right now in some of their chips. So being able to solve extremely transformative problems and apply these types of technology to transformative applications is a massive undertaking, and it's going to require a lot more qubits than is presently available today. So those are a couple things I would say that are causing some limitations, but it's new technology, it's evolving, and at the end of the day, companies have to be sure of how they want to try and implement these types of technology. So that's another area as well. So education, implementation, figuring out what types of problems that these types of technologies can solve.
Is there a perfect or a better timing to this? And is there a plan companies should be adopting to get ready now? Or is this numbers of years' time away?
I mean, quite honestly, I know there's leaders out there that have said, it's 15 to 30 years away. In my own opinion, I think it's much closer than that, just because of, the advancements and changes, even from 5 to 10 years ago. AI quantum was not really in the limelight, right? There were a few major players that were interested in the space, but you can think about 5 years ago what we were focused on, big data analytics, to now machine learning, AI, quantum computing. I think another advance, us advancing another 5, 10 years. Quite honestly, I think there'll be quantum computers that are orders of magnitude much faster than what's presently available. And then the roadmaps and playbooks that a lot of companies, for example, like IBM, they've invested about $150 billion over a particular time span to make sure that they get this right. With those types of investments, and then the wave of quantum campuses that are also popping up in Boston and Chicago and many other places in the nation, DC area as well. I think these advancements are going to, be much closer to present day than, let's just say, 15 or 30 years from now. As far as how leaders should be thinking about this, quite honestly, in the same way that AI has taken the world by storm, teams by storm, and has kind of left business leaders struggling to figure out how they're going to implement this. I think it's going to be the same thing with quantum. So recognition and leadership buy-in, for one, recognizing that this is important, getting buy-in and education. Second thing is finding a trusted technology partner. So an entity or person or team of people that are experts in this space or early adopters in this space and are willing to pair up with them to drive this forward. And then the last few things, driving it forward in terms of strategic readiness assessments, understanding the landscape of investments. You can't forget about governance and security, of course. It's something that can potentially cause problems. I assume we will be able to dig into that a little bit more as well today. And then understanding the deep business impact, human capital and workforce applications. And then before you pilot and test and do a lot of massive enterprise investment and rollout, you got to make sure that you're capturing the accurate data points on a local small pilot phase or regional model before any sort of enterprise or global rollout. So, after that, you just got to make sure change management, monitoring, and continuous improvement is a part of your plan as well.
Is it hard to find people who understand quantum computing and AI today? And should companies start finding those people now, invest, or should they wait until the technology is more mature to get that, I'm assuming, unicorn?
I feel like it's the age-old question. With every advancement in technology, we have to try and figure out who we have on board that knows about that technology, or is, it's previously undocumented interest within your workforce or areas, pockets of excellence that live there. And if that talent isn't in your organization, you have to figure out how to get it in, educate it in, hire it in. Maybe it's gig workers or contractors, maybe for a defined set of time. But ultimately, you want to make sure that expertise lives in house. It should be a high priority. But as we think about this, the pairing of quantum and AI, maybe we can just call it right now quantum AI, it can be extremely niche, right? So you have potentially researchers, professors, budding experts that live at universities, if you will, for a period of time, academic experts. Let's just see if we can have those quantum computing experts that have elements of interest in AI to adapt these types of technologies to present day problems within AI as well. So, it can become extremely neat. You have AI experts, you have quantum experts. If we pair those two together, the percentage of people that have that expertise decreases, right? So it's important to either find them, the people that have one or the other area of expertise, and then interest in the other, or find a way that you can build a pipeline internally or some sort of uh, relationship with the powerhouses that are out there in terms of universities that have expertise, disciplines on their campuses, and then build a corporate slash education pipeline so you can have a stable amount of people that are interested in your firm, or just you're running projects and programs and research at those universities so you can naturally build interest and a pathway into their organizations.
We've talked, Justin, about the benefits. Like I'm assuming most technologies, there's risks. So technically, I read a lot about, quantum's ability to break Bitcoin, quantum's ability to break encrypted systems. Are there new security risks coming that were introduced by quantum systems? Are there ethical issues we should be thinking about now and preparing for before the technology becomes widespread?
Absolutely. I think this is probably one of the most important pieces of this technology. It does present an imminent threat, especially to those highly regulated industries that are out there. So of course we can think about healthcare, of course, as it relates to personal health information, um, financial information as well. So you have the rise of crypto investments on blockchain, and a lot of these investments, of course, or accounts or things that happen as currency is in transit, it's locked down because of the current technology that we have as it relates to cryptography. But those things are based on certain cryptography standards, right? So we'll give a little bit of imagery to this, right? So there are some problems, of course, that classical computers leveraging those cryptography standards, they can take an extremely long time to break, right? So let's just say 50,000 years, probably at the smallest time frame. As of right now, some of these things may take upwards of 500,000, a million, 10 million years to crack or break or solve, if you will, if they're bad actors, obviously. The emergence of quantum computing can solve or break some of these encryption keys in a span of 5 minutes or 5 seconds, depending on the character length or whatever it might be, right? So you can think about this, right? You have global exchanges, you have indices, of course, that are running nearly 23, 24 hours a day. London Exchange, New York Stock Exchange, Chicago Mercantile Exchange, like all of these entities that process information all at nearly light speed as of right now, right? But as we think about bad actors emerging, leveraging this type of technology, and most of the time, bad actors are much quicker to collaborate than the people that are trying to protect the information. So again, if we have investments going out from major companies, but they're not willing to collaborate to make sure that ultimately these exchanges or transactions are safe, but bad actors are leveraging this same technology and willing to collaborate much faster in order to, solve their problems, which is breaking into things, is going to present some problems. So one thing that happened recently, 16 billion, I think it was 16 billion passwords cracked. It was Apple phones, Android phones. So in my opinion, and some of these things are happening in government agencies in the US as well. Right. So when we have all these things happening, we may not see the effects immediately, right? um, PII being stolen, social security numbers being stolen, passwords being cracked and hacked. A lot of these things, unfortunately, uh, they're bad actors holding on to this information, right? So harvest now, decrypt later is happening, right? So once quantum computing starts to come online, now bad actors can greenlight just information that they've been holding on to for a month, 2 months, 5 years, and immediately break into whatever it is that they want to gain access to. So I mean, quite honestly, it's something that is extremely scary from a personal standpoint, but obviously from an enterprise standpoint as well. Companies have to be willing to invest in post quantum cryptography. So organizations in the US like NIST, National Institute of Standards and Technology, they have some new cryptographic algorithms that they're designing, of course, to resist both classical and quantum attacks. But when we think about this going forward, there has to be those security protocols and technology that are put in place alongside, of course, some of those governance and ethical considerations as well. So I know I said a lot there, but that's a huge problem that is emerging, and it has the potential ability to disrupt uh, operations as they're happening today. And from an ethical standpoint, if there is data that is incorrectly influenced or hacked into, and it is data that is trained into AI models, of course, it can have the opportunity to continue to disrupt or accelerate speeds of disruption when it comes to inequities that persist in today's age.
Gosh, a big answer, but a big topic, I think, as well.
Mhm.
So apologies for that. That was a really great answer. What progress do you expect to see in the next, say, 3 to 5 years? Are there any breakthrough or aha moments or announcements that I should be looking out for to know, right, run hard and invest deep because this has arrived?
I think I'm a little biased, but I'll give my unbiased opinion and answer as well. So, Quantum Roads, we are an IBM Silver business partner, and we specialize in AI workflow automation. But, with the advancements right now, we're aiming to have our clients scale into quantum efforts in the future, right? So, giving them a great baseline now in order to set them in a great position in the future as it relates to this type of technology. So alongside that, of course, I mentioned before that heavy investment by IBM, $150 billion, but you see a lot of nation states investing heavily as well. Of course, the US, Germany, China making a lot of advancements and investments in this space. And quite honestly, there is a quantum race, right? Quantum supremacy is something that, of course, is floating around nowadays. So, it presents challenges depending on what nation states' priorities are or enterprises' priorities are. You want to make sure that you're able to have some sort of advantage, of course, when it comes to this technology. So, when I think about what's happening nowadays, of course, it's exciting from a perspective of wanting to make sure that this type of technology is used in the best way. I'm very optimistic that enterprises will see the value in collaboration. So entities like Rigetti, D-Wave, Quantinuum, of course IBM, of course the major players that are out there are also making investments like Amazon, AWS, Google, and Microsoft. So a lot of major players, a lot of major investment, right? So it has the potential to, be a very great situation if these people and these companies make sure that they collaborate in the best way to get ahead of bad actors that will most certainly emerge and are quite honestly are, if you will, lurking in the shadows with utilizing this technology. So, at the maturation of all of this, I think there is obviously a quantum and classical hybrid model, right? So classical algorithms working alongside quantum computers to help solve problems, and the problems that they can't solve, pass it off to the quantum computer. and then once it's solved in a span of 3 seconds or 5 minutes or whatever, what have you, passing that output back to the classical computer to run there, right? So I quite honestly, I don't think there's going to be a lot of replacement as of right now of quantum over classical, but I think they'll start to, of course, collaborate, work seamlessly, and integrate seamlessly in order to tackle some real world problems. And then hopefully the advancements of quantum computing will start to take care of those faults or those issues, of course, when it comes to the fragility of qubits. So it's something that's very exciting. I'm optimistic. I'm really optimistic about some of the use cases and industries that can take advantage of this, like healthcare and financial services, and then obviously supply chain. But it's something that I think is going to emerge most certainly in the next 5 years or so into 2030.
Gosh. So we live in exciting times. I thought AI and agentic AI and generative AI was exciting, but this feeling that if we can get quantum computing working, it feels like we can solve lots of society's problems. It also feels a little bit, Justin, there are risks there, so bad actors do get hold of this. And as you mentioned, they are harvesting already. And let's be honest, people don't change their passwords in that many years. So 3 and 5 years isn't far away. But if we get it right, protect it, put the right tech in and solve the right problems, we could be in a much better place in society. And as everything, those companies that hit the right timing, put on their bootstraps and run to get, as you said, it's not just talent, it's tech, it's money, it's understanding, it's the risks, it's everything around this. Typical, for one of a better phrase, without putting the technology down in any way, typical IT problem, but it feels bigger and everything else. Thank you, Justin.
I
If
agree.
people find out a little bit more about you and your excellent content, how do they go about doing that?
Yeah, absolutely, absolutely. So, folks can find me and the company Quantum Roads, spelled RHODES, on LinkedIn. I'll make sure I can have some of that information in the show notes as well. QuantumRoads.com on LinkedIn, and we're very excited about the advancements and some of the things that we have queued up, lined up for the next few months. We're operating out of the DC area, but we have clients all over the US. And we're also planning an AI related event in collaboration with IBM and the local tech ecosystem in Arlington, Virginia, that is well positioned for leaders to take advantage of in order to see how they can solve some of their problems leveraging AI and some of the other products and solutions and tools that we offer as a company, and of course our partner IBM offers as well.
The future's bright. The future's AI and quantum computing together. I'm very excited.
Yes.
Justin, thank you. And audience, thank you very much for listening in. Until next time, stay safe.